Hello, I'm Mr. Charlie and welcome back to Physics A, Lesson 5, Projectile Motion. So this is our third and final lesson in the area of kinematics, the study of velocity and acceleration and displacement and time. And so after this, we'll be moving on to the deeper question of what makes motion happen, what causes acceleration, rather than just how does acceleration affect velocity and displacement and so on. So also today we're going to be branching out and talking about the motion in two dimensions, a motion in a plane rather than motion in a line. Up to now we've been concerned just with one-dimensional motion, so this is a 2D motion. It's a big deal. It's very exciting. However, don't worry, it's not very hard. You already have all the tools you need to analyze it. We just need to develop the concept of breaking. All you got to do is break the 2D problem down into two one-dimensional problems, and we'll solve those just as we've been used to solving them all along this course so far. So that being said, let's get started. As I said, today we begin broadening the scope of the problems we can solve and moving from the line out into a plane, like parabolic motion. We've been doing problems with forward and backwards motion, but consider a ball being tossed. That moves in a parabola, right? So now we're actually going to have to use some of that vector trig stuff we developed earlier on in the course. Otherwise, you can't deal with a complex motion like this just based on negative and positive. Not going to cut it. So this might seem complicated at first, but again, don't worry. We already have all the tools we need to analyze it. The key is to realize the motion in the x direction and the motion in the y direction are completely independent of each other. That the horizontal motion does not affect the y in the slightest, and the y motion does not affect x in the slightest. The only thing that makes this a parabola and not like the arrow, a vertical shot going up, slowing down and falling back down, is that it's the same thing. It goes up and then comes back down, except it also has a simultaneous x velocity, a constant x velocity that carries it like this. So as it goes up and then it flows and comes down like this. So it's exactly the same as before, but with an additional x component, and that's it. So parabolic motion is just an object rising and falling while motion forward at the same time. And so we'll have our y, as we're used to, will just be given by y equals v sub I y, the initial velocity in the y direction. That's the only difference, times time plus 1/2 gt squared. Again, the only difference is this little y subscript to indicate that this initial velocity in the y direction, not in the direction of motion. So then we'll have that x equals v sub x times t. Constant velocity, again, we'll just split this into the vertical and horizontal problems. And the easiest pie, again, subscript x to emphasize that this is in the horizontal direction, not the motion, not the direction of motion. All right. So like I said, the best way to see how this works is just to do an example and see how it works. So consider a marble rolling off a table of height 0.755 meters and striking the floor at a distance of 24.3 centimeters from the edge. Calculate the initial velocity of the ball. So we're given the height that it falls and the distance that it travels while it's falling, and we want to find the initial velocity. So the strategy is going to break this up into a vertical component, a vertical problem, where the ball just falls down off the table, and a horizontal problem where the ball just flies straight in a straight line across the room. So how does this work? If we want to find the initial velocity, so the initial velocity is entirely in the x direction, right? If it rolls off the table, it's going to fall something like this. And there's no y component at first, just x.